So is my screen visible to everyone?
Yes.
Great. So, last time we discussed about basic data types. What are basic data types such as list, tuple, then dictionary, then set. Primarily, we looked into four data types, four important data types. Now, today, we'll be looking at if else conditions, then functions. What are functions? And before that, we just wanted to briefly talk about certain operators in Python. Like for example, arithmetic operators, logical operators for doing simple calculations. Let's say we would like to do certain kind of computations, mathematical computations. So how can I do that? So you are familiar with this structure, 3 plus 7 equal to 10. You know that. So this is additional operator. Similarly, minus sign is there, it will work. Similarly, comparison operator, less than 3 less than 15. So that means to say it is doing a comparison, less than, greater than, and so on. And now when you are evaluating an expression means to say if you are connecting two or more than two variables, if you are placing two or more than two variables at a time, how it will behave, or which operator gets priority over uh, another operator. So those kind of things are evaluated through our expression. So, like for example, when you are doing 1 plus 4 into 3, the precedence for 4 cross 3, i.e. the precedence for multiply operator is greater. So when it is computed by computer, 4 into 3 is evaluated first. 4 into 3, 12 plus 1, it has to return 13. But why this operator is given like that? So let's do computation. What happens here? 1 plus 4 into 3. So it will give the result at 13. Here there is a mistake in slide. So then we have operators like plus, minus, into. This is slash is division. So when you would like to divide one number from another, this is simple. And this one operator, you have to understand about this operator. This is known as modulo operator. So modulus operator is nothing but a reminder. Let's say if you would like to say, let's say 10 modulo 3, that means to say what is its reminder? The reminder is 1. So this is a modulus operator. It gives you the value of reminder. Uh, and then there is this double star. For example, when you do 3 into 3, it gives a result 9. It is simply a multiplication operator. But when you do 3 double star 3, then it acts as exponent, 3 to the power 3. So this will give you a result 27. Okay. Then you have a role of uh, parenthesis. So parenthesis means to say, uh, like when you have multiple, when you would like to evaluate expression, first expression at one time and next expression at other time. Like for example, 1 plus 3, if you would like to evaluate the expression such as 1 plus 3 first and then multiply, these kind of things can be achieved using the small bracket and big bracket. Small bracket, open parenthesis, and close parenthesis. So then there is division. So whenever you are simply dividing an integer number with another integer number, so the result is integer division. So integer division means to say it will not give you a result in decimal number. So integer means to say it is whole number. Let's say, for example, I would like to divide 9 with 4. 9 divided by 4. So here 9 is also integer value that does not have a decimal point, and 4 is also an integer value. So the result of these two integer number division is also an integer. So that means to say it will not give us value into decimal points. So having said that, it has to return a result as 2. Okay, but now this has automatically been fixed in this latest Python 3, Python Anaconda 3 version. Now it is giving the whole number representation. But when you talk about the Python 3 version, this was Python 2 version. In Python 2 version, it gives like this result, integer. Okay. Then there is modulus operator. Now there are many functions. Now there are many functions, for example, built-in functions. So functions are nothing but to execute certain kind of functionalities through Python. Let's say ABS means to say absolute value. So that means to say, for example, let's consider we have a value like x equal to 1.234. And when I say ABS of x, so now it does not have any changes. But let's say when I say x equal to minus 1.234 and I do absolute of x, what it will result is the positive number. So minus 1.234. So that means to say this function ABS function provided a number, provided the value output in absolute one. So that means to say without a sign, without considering a sign. So having the result always positive, irrespective of the sign. So similarly, there is a cell and floor. So cell means to say, let's say I have a value like 1x equal to 1.4. Now if I have a value such as x equal to 1.4. Now if I do cell of x, so what it should regenerate? So it will give the ceiling value. Cell is not CEIL, cell of x. I think this functionality has been changed in Python. So this the cell command was working previously in Python 2.0, but now for executing this cell function, so what you have to do is you have to import math module, and using math module, you just have to perform this math.cell. Okay. So for importing math, if you say import math, so the math module is imported now, that is available now. Now after importing this, we have to do is math dot cell of x. So now when I do this, so it resulted me into 2. Okay. So now what we are doing here is we are importing a package. So package is nothing but
What is meant by cell?
cell is nothing but uh, ceiling, just a floor and shell. House shell, house ceiling. You understand house ceiling? So house ceiling means to say that, for example, if the number is 1.8, it will cast it to 2. So that is shell. Shell means to ceiling, house ceiling.
All right. Okay.
And similarly,
So
floor means, yeah. So whenever you have the lower number, it will cast to high. For example, if there is something like 1.2, when I do math dot sale of 1.2, even it will cast to up. So that means to say the result will be 2. It is bringing the decimal value to upper level, ceiling. So similarly, there is a floor. So what is the function of floor? Math dot floor. Now, when I say, let's say there was, even if there was a value like 2.8, now it should cast down its value. Down, it should downgrade its value to 2. Okay. So math dot floor resulted in value like 2.8 to 2. So these type of small functions will be very helpful when you are doing certain kind of computations. Like, you might have certain functionalities where you need to cast it down or cast up certain values to some fixed integer number or something like that. So at that time you will be using that. So for doing that thing, what you have to do is you just have to import a math module. So math module is nothing but it's a it's already built in functionality in Python programming language itself. So because it is Python, because it is built-in functionality in Python language itself, so you have to initially bring it to your IDE. So think it as an IDE. So this code you can, wherever you write this code, you can write into Jupyter, or I'm just writing here into cell command line itself. So initially what you have to do is you have to import a math library. So import math. Then what you have to do is, using the math library function, using the math module, you just have to call cell, floor, or whatever other functions as well. Let's say other functions, right? As this documentation is old one, because this documentation was created for Python 2.0, and nowadays most of the Python 2.0 versions have been almost deprecated. So Python 2.0 is almost around uh, in the form before 2008 or 2010, 2012. So this was purely at that time. So this happens like this. Now when you have to create a log value, if you have to do log, let's say you have to perform a log of math dot log of 100. So by default, log of 100 means to say it will be of base 10, not base 10, it is of base 2. Log 10. For log 10, what you have to do is just you have to use the functionality of log 10. So just log means to say it is base e, log of base e. So base e means to say the value of e is something like 2 to the power something, right? 2 to the power 3, 4 power something. So this is something like that. So log 10 means to say logarithmic 10th the base. So that means to say when you do math dot log 10 of 100, now it should result into 2. So you understand log, right? Logarithm.
yeah, we do understand.
Yeah. So logarithm is nothing but just a power factor. Power factor of 10 in case of log 10. And in case of natural log or e, it's the power factor of e. So the value of e is e value 2 point something. So this is something, this 2 point something. 2.71. Okay, similarly, you can have this max function, mean function, round function, sine function, then square root function as this slide. So for example, if you have to compare two values, which one is max or which one is smaller or which one is larger, math dot max of, let's say, I told math dot max of 100 comma 80, let's say what it gives, math dot max larger
So
round
for
value.
every function we have to type math.
Not every function, because this is included in math module. Whatever functionalities are available in math, yeah, of course, for math, whatever functionalities are available in this math package, so you have to use, yeah, using that. So previously these functions were in Python 2.0 version. These functions were by default, you don't have to type, you don't have to use you don't have to do like math or something. But now after 3, the things has been changed and it has been object oriented. So that means to say, uh, these attributes has to be accessed in object oriented fashion. So because of that thing, this has happened. And even this math dot max module is not working here. So there might be some documentation change. So if you get any kind of problem, something like that, so you just have to always go to this docs.python.org. So, so this is the official documentation site. So where you find the latest functionalities, whatever are implemented into this. So like for example, python.sale, python.com. So choose, this is about combination. So out of n, choose choose k. Out of n, choose k. How many will be there? So the function is like n factorial divided by k factorial into n minus k factorial. So combinatorial, you can do like that. Then the copy sign, then this absolute value. Factorial, for example, factorial, if you would like to have a factorial of something, let's say math, you want to perform the factorial, math dot factorial factorial of 5, let's say. So it will directly give you the value 5 into 4 into 3 into 2 into 1. So lots of many functionalities and many functionalities are there. So you can just check these documentation based on, sometimes, for doing some scientific computation, you might need certain kind of these math functions. Like for example, here GCD, greatest common division, right? So these, if you have to manually code, you can do these things through your own manual codings also, by doing if and else condition, then dividing and doing some xyz operations and all. But someone already has done coding for you, so you just are using their functionalities. So this is nothing but usage of function. So I will tell you what is just function. So let's not go deep into this. I just wanted to show that there is math module for working with math functionalities, and doing certain kind of things easily without doing your coding. So uh, let me go through this. Let me open Jupyter. Okay, let me open Jupyter notebook, and we shall know or understand about the function. So now my Jupyter is turned on. I think this notepad, this Chrome, this Explorer does not support much more the Jupyter notebook. You can just copy this URL and paste it here into Chrome tab, Chrome browser. Okay, now I want to create one simple new file in Jupyter. Here is new option, and I just wanted to create new Jupyter file. And let's say I'm doing exercise. I just want to rename this file name. I just say function examples. Okay. Now you have to understand, let's say, whether it is working or not. Okay, it's working, it's fine. Now you have to understand what function is. Somebody has messaged me. During this 2-minute waiting time, can you please explain about topple? Okay, I'm sorry. Okay, we'll discuss at the last time. Before finishing lecture, we'll discuss. Okay, so we were about to discuss about functions. So before discussing function, as you saw here in the examples, and you might have probably guessed about what function is. So like when you do sale of X, so it computed and it did computation in the back end and provided you certain output, right? So in real life also, what is a function? A function is nothing but it takes certain kind of input, and based on input it gives me certain kind of output. In mathematics also the same thing, the same concept we apply here uh into Python also. So that is something, that is a function. So that means to say, like, these are the functions. Like for example, shell is a function, so floor is a function, log10 is a function which is doing a logarithm, and factorial is a function. So in the same way, we can create our own functions. We can create our own functions, own our customized functions. So why we need function? So basically what happens is when you write codes and codes and codes, the management of codes is very difficult. For writing a single line of writing thousands of line of code and doing and evaluating and watching what X is doing, what Y is doing, or what this line of code is doing. So it is very difficult to trace and do code in a without a function. So because of that thing, so function give us an easiness to write a code and to explicitly tell that yes, this 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 has an objective to do X thing, this has the objective to do Y thing. For example, here what we are doing, this cell has an objective to bring the decimal value to an upper level. So similarly, floor brings the value to down level. So as similar manner, so we can have our own function. So how can we create function? Our customized function. Let's say that we would like to create a function such as, let's say that we would like to create a very simple function like computing of sum of two numbers. Very simple function. So for doing that, what we'll do is we have a keyword known as def. Then we give the function name def sum, and we just have to open the bracket and close the bracket, and we just have to put this double quotes and hit enter. Now what we have to do is, let's say it is simply what is doing, it has certain variable, it has certain values. Let's say X, let's say there is a variable called pi equal to 3.1416, and radius, there is a radius variable, radius, radius variable is there, and whose values like let's say it is a circle and circle's radius is 3 mm or something like that. Now we would like to calculate area. Let's say this is not sum but area calculation. Okay, area. Now what we would like to do is we would like to calculate an area, and we know that the circle of area is pi r square. So let's compute an area and keep area result into variables such as ar. So area equal to pi into radius square. So radius. Now how can I do square? So for doing square, we just have to do double star, and we have to type this. Okay. Now you are computing radius, and let's print. Now you are computing area. So that is nothing but an area of a circle. So print area of circle is how much? I did comma here, AR. Now this is just template. This is just template area. We have a template function where there is a function area, where we have defined two variables, pi and radius, and then we have computed certain things and we are just printing it. Now, wherever we would like to compute, wherever we would like to use this, we can directly use it. We can directly use it. How can we use it? Let's say if I have to calculate the area here, I will just copy this. I will just type area and just hit enter. So what it will do, it will execute our functionality. So whenever I call this function, to call this function, I just have to do is area. Simply I just have to write area, then close and open and close bracket. So when I click enter or when I click run button, so what it will do is it will execute the functionality. Like it will first initialize the value pi equal to 3.14, then radius equal to 3, area equal to pi into radius square, and then print area of circle. So it will give me the area of circle. And similarly, whatever number of times you compute this from wherever you would like to compute, so this will do like this. So let's say that I don't want to have this variable fixed. I want to pass it from outside, from here. Okay. So for that, what I would like to do is, so what I will do here is, instead of this, I'll just pass this as a parameter. So I'll say like pi, comma, radius. I will pass this parameter and I don't want to fix these values here. Now my function is just a template saying that it accepts pi value and it accepts radius value and it calculates something and does something. Now when calling an area, so what it is asking, so for example, when I do simply like this, it give me an error. So saying that area missing two required positional arguments. So that means to say, so these are known as arguments. Okay. So these are known as arguments. So when we pass from here, so these are called arguments, and when these are here, so these are known as parameters. So in function, we call it as parameter, and when we pass from here, we call it as argument. So these are the same thing, but different name conventions. So area missing two required positional arguments, pi and radius. That means to say it is asking for entering the value of pi and radius. Let's enter the value. Simply directly we can enter the value like this. Let's say pi value is 3.1416, comma, radius value is, let's say, 3. Now if I try to execute this, so it computed its value. Okay. So let's say now my radius has been changed and I would like to, let's say there is something different and my radius is changed to 6. Now what is the area of that? If I click and execute that, it computed on my area, telling that area of the circle is 113.0096. Okay, so this is nothing but a function. So do you have any questions so far?
Yeah, I have one question.
Yeah.
Let's say we have different diameter, many many circles of different diameter. So can we compute it at one time?
Many circles of different diameters.
Yeah.
So diameters means to say radius, or what do you mean by
Yeah,
that?
yeah. Okay, radius. Sorry. Okay, radius. Like 3, 6, 9, 12, 15. We have many circles of different radius, and now
Yeah,
we
yeah,
want to
yeah.
compute at one time. So
Yeah. So what you can do is, so you just have to, you can do that. So how can you do that is using the type of structure that we previously studied. Now, instead of radius, let's say that radius is now just a single variable. Now, instead of radius, what we would like to do is we would like to have radius that accept the list of variables, right? So list of radius as a parameters. So that means to say we would want values like this as a list, radius list. For example, there was something like 3, radius list is 3, then second radius was 4, then second radius, next radius was 5, and next radius was 9. Now when you do that, now it does not work. It didn't work. So why it didn't work is because so our radius here is our radius here is, we are providing a radius as a list, but here we are accepting radius as a variable. So firstly, what we have to do here is we just have to iterate through each of the element of radius. Then we have to calculate the functionalities for that. So that means to say, now what we have to do is, I just have to loop through this radius, each of the element of radius. So let's loop. I say for r, for each radius in radius list. So now this is nothing but radius list. Okay. So I just change the variable name for each radius in radius list. Now what I would like to do is, for each radius, let's not change this. I just change the radius. So for each radius in a radius list, what you have to do, and you just have to compute area. Area equal to pi into radius square. Now when I do that, so this is now capable of accepting the list and perform your operation. So when you do this, so it executed your value, and you can compute the radius of circle one by one for list of radiuses, right? So this is what is your functioning. So based on your requirement, whatever is your need, and based on that, you modify your data structures, and you tune your functionalities based on that, and you execute the functionalities. Okay.
Can I ask one?
Yeah.
Actually, this yeah, I've seen this in during my schools, but I'm not familiar. What are the practical application of this kind of coding? Can you please briefly tell it?
Practical application of,
Like this kind of coding.
yeah, the practical application is, so practical application means to say, whenever you are, as I told you previously, whenever you are working with whenever you are working in a big project, so
Mhm,
you have different kind of functionalities for different kind of things, right?
mhm,
For example, some functionalities might only be focused on calculating certain kind of observations. Let's say calculating an experimental work for reactions related to some XYZ chemical,
mhm,
and the next component might be concerned with displaying the hydrophilic or hydrophobic properties, or the next one might be related to saving it, and or the next one might be related to displaying your result to certain things, like displaying or saving result to your CSV Excel sheet or something like that. So when you have different kind of functionalities, so
mhm,
when you have different kind of functionalities, so when you try to do different kind of functionalities through a single line of code, through static line of through list of procedures and list of lines only, so
mhm,
what happens is your code becomes difficult to manage. Your code becomes difficult to manage, and it's very difficult to understand, even
mhm,
understand and manage those things. So for
mhm,
that thing, you need to organize your code into structured way, so that other can use it, and you also benefit for it. So for example, let's say for example, so we once, for example, here what we did was, we just calculated an
yeah, yeah,
area
yeah.
for a circle that accept your radius list.
Mhm,
Okay. Now when we defined this function, we define
mhm,
it only one time. Now
mhm,
wherever we need it, we can just call it. We don't have to do anything. Let's say I have next, let's say I have um, next function, such as I have different kind of parameters, 4 8, let's say 0 something different,
mhm,
4 8, like this. You can think that these are the different kind of experiment or something result you are
uh-huh,
trying
uh-huh,
to compute, right? So whenever you would like to execute this will execute. Now what happened is, because you have created a function,
mhm,
so you don't need to write it everywhere. So if
mhm,
you have not created function, you have to write it here also. You have to just write it full code here also, and then you have
mm,
to do the thing, right? So
yeah.
because of that thing, now you shortened it. You just call this function wherever you require, and you just change here values, data values only,
Mhm.
and it is done. the practical scenarios of these is, let's say that you are writing a program, to save your experimental data to
Yeah.
Excel file, right?
Mm-hmm.
You might particularly like, you do certain kind of experiment and you'd like
Mm-hmm.
to save that result to Excel file.
Yeah.
So if you write some kind of function if you write certain kind of function that saves your data to Excel file, so you just to create that function at only one time, and then you
Uh,
use everywhere, right?
mm-hmm.
Like for example, here also in math, this is the Python already built in math library. So they
Mm-hmm.
have created function like absolute, logarithm, then factorial, and so many others. So because we don't have to code it for every time, we just use it, create call, write once and use everywhere. So this is
Mm.
something known as function.
So area of circle is just an example.
Yes, area of circle is just an example. This is just to demonstrate that how you can
Uh,
practically use it to your application and all.
okay, okay.
Yeah. Okay. So next thing is, let's say now here, as we see here, we have imported the module as like here. As you see here, we just imported a math module somewhere. Here anyway, yeah. So here we have imported a math module, right? So similarly, we can import our own module also. Let's say that this is our module. This is our module def area. So this is our module, and I have some new file. Let's create some new file. Let's rename this file as module. Okay, function f1. Let's rename this file as f1. Function example dot py. Okay, let's rename this as function example dot py file. Function, okay, f1 dot py file. f1. I want to change this to module, f1 underscore module. Let's say this is similar to Python module, f1 dot module. Okay, I just changed this, and let me create some new file. Where I would like to import this module functionality. I just want to reuse this functionality into some new code. So how can I do that? Let's say I just created this some file. Let's say my new, let's say test one, something like test example, something like that. And now what I would like to do is, so this is my next file, or this is my next file, or entirely next file. And what I would like to do is, in this file, I have many different computations, and I also want to use this facility, use this functionality, which is defined here in f1 module, right? So for doing that thing, what I have to do is, I just have to import this as a module. So what I have to do, I just have to import, means to say nothing but include. So import or include f1 underscore f1 underscore f1 underscore module, module. So when you do that, so it imported your module. Now if you would like to use this functionality, what you have to do is, you just have to use the module name and call the functionality f1 underscore module dot, I have a function area, yeah, area, and let's say the area value I have this one. Okay, so when I call this, so name f1 module is f1 underscore module is not defined. So as this is not saved into exactly into f1 underscore module dot py, because this has been saved into ipynb. So what we have to do is uh, we just have to create purely Python file and save it. Let's say new notebook, not new notebook, but not notebook, but let me save it as a Python file. So here, new, if I say text file, and I will rename this as, let's say, f1 underscore module dot py. So py means a Python file, f1 underscore module dot py. Okay. So this is a Python file, and simply what I would like to do is I would like to have this function included here. That's all. So I just have this function included here and I saved it. That's all. And now I would like to import this. Now I would like to import this as a module here. This is not working in this Jupyter editor. I think for this we need to use another one editor. So maybe Spider or something. We'll see it later. Let it skip as of now. So because this is the Python Jupyter, Jupyter is for basically for browser-based environment, so this is not supporting. Here I have created f1 underscore module dot py, f1 underscore module dot py, and this py file is already there. And language, if I say Python, Python. Okay. So even if it is saved, let's say I have saved it. Let me restart this kernel. Restart and clear output. Restart. Okay. Let it run without anything. Let's here I want to include that f1 module. Let's see if it works. Dot, we have a functionality area, and here in area, what we have? We have nothing but two values. Let's say something 3.14, comma 1, comma 2. Okay. So now here it worked. It was not working because I created a file and this kernel, this engine was not restarted. So because of that thing, it was not working. Okay, so ultimately what I was trying to convey you or understand you is like your functionalities can be anywhere, wherever you would like to reuse your functionalities. So you just to create your modules. So modules are nothing but list of functions that are included or separated into included that are created into separate files. And whenever you need this, you utilize these functionalities by using this kind of thing. So initially you say import. So import means nothing but include. Include. What to include? Just include this F1 module. So F1 module. So this F1 module is nothing but whatever is the file name of this, you just remove .py extension, and before that whatever name is available, so you just have to keep that name, F1 underscore module. Okay, so import F1 underscore module. Then so inside F1 underscore module, what we have, there might be many functionalities. Like for example, this is one area function. There might be some other function that is calculating the color. There might be certain function that is calculating the color, or there might be certain other functions doing saving or certain kind of things, behavior. So now what you have to do is you just imported a module, and then using that module, whenever you have to call the function, you just have to use name dot area name dot function name. Like here, if I have to call this one name dot, let's say that I want to create some, let's say that I want to have some new function. Just I want to create new function here, def hello function. Just I am creating hello function and say hello print. I'm just writing nothing but print. Print. What am I printing? Hello. I am called from module. Called from module. I just typed this. And now if I would like to call hello function, now what I will do, I just will call this hello function using F1 module dot, I will type this function name, hello, H-E-L-O, hello. So when I click this, now this is not showing, this is again saying that the F1 module has no attribute hello. So that means to say I need to restart this kernel again. So restart and run out. Okay, now it is called. So hello, I am called from module. So what I did was I just created two functionalities in a module named as F1 underscore module. So module is nothing but set of functions that you have listed into certain file. The module is saved with name with .py extension. It is nothing but a Python file. And when you are calling a module, you just have to initially import a module. So how can you import a module or include a module? So just write import F1 underscore module name. Just you have to give this module name excluding .py extension, and then you have to call the module. The same thing as we did here. So now you correlated this. Now you correlate with this one. Now how this is done? Here it has done import math. Okay, that means to say it wants to include math module, and then from math it is executing shell function, it is executing floor function, it is executing logarithmic function. That's all, right? So now you might also wonder that, oh, this every time F1 underscore module, F1 underscore module, this writing F1 underscore module is very difficult. I want to have certain easier functionalities. Why to type this? Can it be aliased? Yes, of course it can be called with shorter names by as let's say I just want to shorten its name and say F1. Now instead of F1 underscore module, I can use this F1 everywhere whenever I want to call this. Let's say if I say F1 dot area, so this would also work. Okay, so if I say F1 dot hello, So this is the suitable name, whatever the convenient name, because the file name might be because the file name, somebody might have created the file name with different extension and something like that. So it might be very lengthy to use or might be difficult. So at that time, what you can do is you can alias it. Alias means to say, instead of certain name, you can use another name. This is the facility it is given by Python. So this is aliasing, and you just understand working with module. Okay. So I guess we are much done with this. Now, if you have question, we can discuss. And also there was somewhere